Hello folks, let's understand what is FPGA Flow, that is Field Programmable Gate Array Flow. This is a simple explanation of the flow, mainly useful for engineering students or anybody who is preparing for their interviews. Just for a quick brush up, this video would really come in handy. Let's begin. As you can see in the picture over here, this is a complete flow chart of your FPGA flow, starting from the customer requirement till you run the whole design through the whole flow, and finally you configure the FPGA. So let's take each of these stages and try and understand how can we achieve this. Let's begin. As we know, in any of the flows, there is initially a customer requirement wherein the customer says, I need a configurable design. I need to make a configurable chip. So depending on the design requirements and the customer requirements, you have a team of designers. You would have a design head and his or her team members. So whole of the design requirement, right, is partitioned by the design architect. Assume that this is something, the requirement what you've got from your customer. Say you've got a control logic, you've got a ALU, and probably a memory or something of that sort. So in your team, you might be having each of the individuals experts in designing any of these logics. So the design head partitions the design and gives each of the modules to all the other team members. So now remember that in your professional world, whenever you're working, the whole design is a teamwork. That's what the picture shows over here. So each of the individuals take their share of work and go ahead with the implementation depending on whatever the specifications are assigned to them. Next, so the first stage here is the HDL designing. So that is hardware description language. So we have VHDL and Verilog to implement this. So the designer, mainly the digital designer, or we also call them as the RTL design engineer. So they take their share of work and go ahead with the RTL implementation, assuming that it's a state machine or a counter or something of this sort. Okay. Once the design implementation is done, obviously you have to simulate the whole design and see whether you are meeting the functional and the design requirements. So you have to write a test bench for that and run a simulation. So this is a simulator example wherein it's trying to show that you are verifying the functional results. So once you are satisfied with the results, you take a call whether to go ahead for the next stage of the flow, or if you want to improvise your RTL code, you would go back and make edits to your design. So assuming that you are satisfied with your RTL results and the waveforms what you see over here, you move towards the next stage of designing, that is called as the synthesis. So what is synthesis? Synthesis is a gate level representation of your RTL code. So assume that you have written a RTL code, something of this sort, and when you run it through a synthesis tool, this is what you get. It's a gate level representation of your design. So this is mapped to a particular technology, and this is where you try to do your logical equivalence checking kind of a thing, trying to map or trying to optimize your design to the best possible way. Okay, so assume that you are satisfied with your synthesis results. Then you move to the next stage of your design cycle. Now, depending on which FPGA you want to target your design, right, you select the FPGA through the whole process where you want to target your whole design, and then you run the floor plan and place and route. So once that optimization is done for area or speed or power consumption or any other logical optimization, once you're fine with the floor plan and place and route results, you dump a bit file. So what is a bit file? Bit file contains the whole design information of your digital design. So now this is the file which is used to configure the FPGA. So like how we've got a design database in ASIC as a GDS or Oasis, in the FPGA flow, we call it as the bit file. So now this bit file is configured on the FPGA. So you take the design through the whole cycle through either of the tools like Xilinx ISC or Altera Quartus 2 or SOPC Builder or anything of that sort, and then you configure the FPGA. So once you configure the FPGA, so you obviously would want to see the results. So if you're got the desired result, what you've expected, then you can call your design to be complete. If you are seeing any glitches and if you're not happy with the results, you go back and again make edits to your RTL code so that you meet your requirements. Again, your design has to go through the whole flow simulation and again verification, synthesis and all of it, and then again you need to come and configure the FPGA. Now this is a very simple explanation of what exactly is FPGA flow. ASICs and FPGAs have their own advantages. Now depending on where or what application you want to target, you decide whether you want to implement the design on an FPGA or an ASIC. So both of them have their own advantages and disadvantages. Thank you.